right, you guys, today's least squares regression lines. You guys have done these, which is nice. So the first thing we're going to look at is that same truck problem we were looking at before. So the longer that you drive a truck, the more value they lose. Can we predict the price of a used Ford F-150 Super Crew 4x4 if we know how many miles it has on the odometer? So we've got the random sample of 16 of them that we looked up, listed for sale at autotrader.com. And the number of miles driven is given, and the price in dollars are recorded for each truck. So we've got the data, and we've got the scatter plot. And the scatter plot shows a moderately strong negative linear association between miles driven and price. No outliers. Correlations negative 0.815. And the line on the plot is the regression line. So we're going to learn how to find this regression line. So you guys, the regression line is the smallest distance between all these points. Okay, so the formula you're going to use, and you should write these down. Y hat equals B plus AX. This is the one we're going to use. Y hat is very important. You have to put Y hat. So Y hat stands for the predicted value, not the actual value, because if you look at the line right here, the predicted value is going to fall exactly on the line. So I might have a point right here. Well, that's off from the actual value, right? So Y hat means predicted value, and we're always talking about the predicted value when we're doing the linear regression line, all right? And then B, what is B, you guys? Nothing new. You guys have been doing this for a long time. What's B? Y-intercept. Thank you. Okay, and what is A? Even though we usually say M, what's A? Slope. Okay, we go in the other order. This is just how statistics does it. It is the same thing as MX plus B, just switched around. We still have a slope and a Y-intercept, all right? So Y hat equals the Y-intercept plus the slope times X. Now, your formula sheet on the AP test, and the one that I gave you guys, nice yellow sheet, looks like this. It's the same. It means the same thing, right? Predicted value, B sub O. Again, that's your initial amount, or your Y-intercept. And B1 is the slope times X. So don't get confused. They do mean the same thing. This is the one you're going to see on your calculator that we will use. All right. We're going to find the regression equation in the truck problem. So you guys probably want to turn to page 165 because it's probably easier to just read the values out of your book. And we're going to enter them into our lists. So on your calculator, you guys go ahead and do miles, price, enter it into your list, and then we will do the rest once you guys have that all and R. So one place you can actually do it is from this table. Okay, turn this off. There we go. So I usually go up to the top here and go here. All right, so you go menu, statistics, stat calculations, and linear regression. These are the same, okay, but let's use the statistics one. Then you got to enter in which one's your X and which one's your Y. So we've got your miles driven and your Y, your price. Press OK. All right, so this gives us our A, our B, our R squared, and our R, which we'll use. So another place to do it, which you should do. Why should we look at the scatter plot, you guys? Why? Why even look at it if you can find it right here? Anybody know? Yeah, well, or to see if it's actually linear, right? Because can we get a line if it's curved? Yeah, we can still get a line, but we need to see if it's actually a linear pattern. So let's do the scatter plot. So we go control, doc, and we add data and statistics, and we're going to put our miles driven here and our price here, And as miles increases, price decreases. Then we want to put our line on here. So you want to go to Menu, Analyze, Regression, and Show Linear. I'm doing the A plus BX. All right. And, yeah. So let's write these down because we need to find them. So we've got Y equals. Now, in rounding, in statistics, you need to do what makes sense. Yep. So for the miles, we could probably round to the whole mile. So someone tell me that number for the Y-intercept, the B, the first number, or it was like 38,257? Is that what you guys got? Okay. And for the decimal, I would do 3 or 4 for this slope. Point, and someone tell me what that is, Tyler. Awesome. All right. Oh, thank you. Boop.
That's a point off.
Yep, that's the loss right there. Definitely should be negative. Why? Because our slope is going down, and so is our correlation, which should be negative. So identify the slope and y-intercept of the regression line. Interpret each value in context. You should definitely write this down. Okay, this is important. So we want to identify the slope and the y-intercept and write a sentence for what it means in the context of the problem. How many of you guys remember doing this in Algebra 2? Good. Okay, so let's go with the slope. Kyle, what is the slope? Yeah, the number. Negative 0.1629. And someone else, can you interpret what that means given we're talking about miles driven and price? Abby, what do you think? That sounds good. For every mile driven, you guys should write this down, the price decreases by, you don't have to put a negative here because you already said the word decreases, $0.1629. Every time we do slope, your sentence will look something like this. For each additional one something, this one we just said, for every increase in 1 mile, or for every mile, and we're talking always about the x variable first. Okay, for every additional one, whatever your x variable is. Now, this is important, and we should probably add this word in there. The predicted, what do we want to put here, you guys? Okay, slope, which is our y value. Then we want to say increases or decreases by whatever the number of our slope is with units. Okay, so let's go back to this. For every mile driven, what should we add here? Predicted price. This is huge in this section that, again, this is predicted and not actual. Okay, now we have y-intercept. Adem, what's the y-intercept in this problem? Yep. Okay, who can interpret the y-intercept? Let's go with Taylor. What do you think? Yep. Very good. Okay, this is the predicted value of a truck with 0 miles driven. Again, predicted, very important word, value of a truck, specifically the Ford F-150, with 0 miles driven. Okay, you might always think initial amount. In this case, when you start at 0, when you first drive the car off the lot, that's what it's worth. Okay, now they're going to give us, yeah, Jake, which question?
So, like, on the AP test, are you allowed to say A truck, or do you have to say, like, an F-150?
I don't know how specific they'll be. Yeah. Good, yeah. Ford F-150. We might as well be as specific as possible. If a used Ford F-150 has 100,000 miles driven, what is the predicted price? So you got to show your work, which plug it into the formula. When you use the formula, you must use Y hat, because Y hat stands for predicted price. So we have 38,257 minus our slope, 0.1629, and we're plugging in 100,000 miles. Okay, evaluate that, you guys, and tell me what you get. 21,000 what? $967. So the value of, actually, what should we say? The predicted value of a 100,000 mile car, Ford F-150, is 21,967. All right, we have this word called extrapolation. So what if we wanted to predict the value of a truck with 300,000 miles driven? What happens when we plug it into our formula, you guys? 38,257 minus 0.1629 times 300,000 miles. Anyone got it? Donovan? Okay, does that make sense? No. This is called extrapolation, when it doesn't even make sense to use the line of regression for the value you're plugging in. So extrapolation is the use of a regression line for prediction far outside the interval of values of the explanatory variable x. So our x is too big. Usually the predictions are not accurate. All right, let's check our understanding. Some data were collected on the weight of a male white laboratory rat for the first 25 weeks after its birth. A scatter plot of the weight in grams at the time of birth in weeks shows a fairly strong positive linear relationship. The linear regression equation looks like this. Predicted weight, so notice weight has this hat on it. That is the predicted weight, equals 100 plus 40 times the time. Models the data fairly well. So CC, what is the slope of the regression line, and explain what it means in the context of the problem? Yep. Just 40. Yep. It increases by 40 what? 40. Good. That's right. For every 1 week the rat's alive, its weight increases by 40 grams. Okay?
So does the slope not, it's not like grams per meter?
Nope, just your y. Yep, because it's like always over 1. So yeah, just your y. What's the Y-intercept? Charlie, what's the Y-intercept? And explain what it means in the context of the problem.
100.
Good. Yep. When it's born, it weighs 100 grams. All right. Predict the rat's weight after 16 weeks. Plug it in, you guys. After 16 weeks. Owen, you got this?
So do you think it's like a battle, or, I don't know, you're kind of like
You always
Like a
just
word.
put predicted. You always have to say predicted.
Okay, so it just is exactly.
Yeah.
Okay.
All right, Kyle, what'd you get? Okay. So again, be sure you say Y hat when you guys do these. 740 grams. Should you use this line to predict the rat's weight at 2 years old? Use the equation to make the prediction and think about the reasonableness. Yeah, so 2 years, you got to convert that to weeks, right? And then you'd like plug it in, and what do you guys think? Is it going to make sense? No, that would be like a huge rat. So it would weigh 4,260 grams. That's 9.4 pounds, which is the weight of a newborn human. That's called extrapolation. All right. Good time.